Good morning, good evening, good night. It is Friday. It is the last day of the summit for me. I hope everybody's been enjoying themselves. My name is Randolph West. I'm not starting with a slide at the beginning because I wanted to say hi. I have been having a great time despite the fact that I don't have any people to visit in person, but I've had the opportunity and privilege to speak with people during panels and during my pre-con and today as well with you folks. Today, I'm going to speak to you from Calgary. I have a PowerPoint slide and I'm going to press a button here to show it to you that says, "This is me." I am also helped today by Janice, who is the best person out of Victoria, which is the capital of BC in Canada. We Canadians love to work together. I also have a little view here where I'm on the top right here, but I'm not going to use this one much. If I want to speak to you, I'm going to say hi from this camera and then just talk through the slides. Today, we're going to be talking about what it means to be a database administrator in inverted quotes in the modern era. And if you have any questions, please feel free to put them in the chat. The thing about this platform is that there's a slight delay. So if you type the questions, Janice will be able to get them to me and then I'll be able to respond. For those of you who are watching who want to participate, I do have one poll that I'm going to ask you to visit on a web browser, and you'll get the URL. I'll speak a bit, and then we'll come back to see what the results look like. So hopefully that'll work out well. I believe there's around 100 people watching today. Thank you very much for spending the time in your Friday afternoon, evening, or morning. So let's kick it off. Database administration through the ages, presented by me. Of course, you will have seen this slide a bunch of times. Please explore all the things that PASS has to offer. Speaking for myself, I'm already a PASS Pro member because I want this organization to succeed. I want to continue helping present events like this and SQL Saturdays and so forth. And by becoming a member, you can help the organization keep going. There are local groups, there's SQL Saturdays, all of them are virtual. Did you know? This is an interesting fact. Janice and I helped put on the last in-person SQL Saturday anywhere in the world. Did you know that? Well, now you do. We've also got the PASS Marathon, which is like a 24 hours of PASS where you can come in anytime during a 24-hour period and watch free stuff. We've got our virtual groups. We've always got room for volunteers to help out. And of course, you can visit pass.org. Moving on, please, please, please do the session evaluations. Please do the session evaluations, please. If you do it before 5 p.m. today, Eastern time, which is 3 hours from now, then you stand in line to win some prizes. And of course, it helps us be better speakers, because if we don't know we're doing something wrong, then we don't know and we won't improve. So this is me. There's not much to say. I've helped write some books. I've died on an episode of Fargo. I'm on Twitter. I have a GitHub repo. This is the usual stuff, right? The important thing for me here is that my pronouns are they and them, because guess what? We're a diverse organization, including me and you. Thank you for being here. Moving on to the important thing, we have a competition where you can win some prizes. Now, I tried to get some people from Twitter to join me today just to enter the competition to win some prizes. And I'm cheating here by putting the slide at the beginning because I'm going to guess that everybody's going to stick it out till the end, even though I'm putting the QR code up here. And I believe we had the QR code up before the session started. So scan this with your device and you can enter the competition. I'm going to leave it here for 5 more seconds. 4, 3, okay, I lied. So let's talk about database administration through the ages. The first question we have to ask ourselves is, what does a database administrator do? Now back to me again. I used to be a database administrator. I would sit at a computer and I would go into Management Studio, or before that, Query Analyzer and Enterprise Manager. Remember that, kids? And I would make sure that the backups had been run. I would make sure that the agent was running and so on and so forth. But times have changed. We're no longer database administrators. We are data professionals. There is a lot more for us to do these days than just administering databases. We've got a whole bunch of new technologies that we have to think about. We have new hardware, we have virtualization, we have all sorts of stuff. So when it comes to what being a database administrator is, we're not looking in that tiny little box anymore. We're expanding our view to ask what a data professional is. So what does a data professional do? Now, it says at the bottom there that this list comes from Wikipedia and is not original work because I'm a hack. If you are at all involved in database administration or data professionalism, you've got shortcuts for everything. So me calling myself a hack is a bit of a tongue-in-cheek thing because you want to automate as much as you can, right? So of course I automated this list. You got to know how to install, upgrade, migrate, and configure databases and database instances. You've got to be able to resource plan and do capacity management. So is this database getting too big? Well, we're going to need more space for backups and so on and so forth. You've got to be able to modify data structures, tables, indexes, that kind of stuff. And you've got to be able to do query tuning. And then Kenneth Fisher, who is one of my dear friends who's currently in hospital for an operation, he is one of my go-to experts on security, especially around user security. But the thing is, we're all expected to do this stuff ourselves. We're not, some of us are in a team and that's cool, but there's a lot of single people in a shop which is having to do all of these things. And that's tough. I understand that that's tough. Compliance, that's a huge aspect that we have to deal with these days, especially when it comes to security and making sure that the right people get access to your data. What else? You've got to manage high availability and disaster recovery. This is a huge, huge topic to discuss. When we talk about high availability and disaster recovery, they're not the same thing. Disaster recovery has to do with making sure that you can recover from a massive problem like a power spike or your entire machine goes away. Whereas high availability is making sure that everybody can access the stuff at all times during the day. You've also got to be able to do querying for your other customers. So here's the thing about being a DBA or a data professional. Your customers are inside the organization and they're also outside the organization. You have to treat everybody as though they are your customer, and you have to treat everybody as though they are your only customer. Because if you treat everybody the same way with respect, then they will treat you with respect. And then when you do have to say things like no, then they understand that it's coming from a place of understanding. You've also got to monitor the data estate. That means the same thing that I mentioned before. Go into the computer, make sure that everything's running. Fortunately, there are tools to help you do that these days. We've got scripting, we've got automation tools, and that helps you monitor things. We've got even some of the sponsors who are here this week offer amazing tools for monitoring your data estate. And by the way, I'm going to plug the sponsors here. If you haven't spoken to the sponsors at all this week, I encourage you to. There's still some time. I would allow it, even if you're not going to stay in this session, to go and speak to some sponsors. I'll allow that. And as I said, you got to deal with customers, internal and external. So all that stuff that we spoke about, what do you do right now? You've also got to know other stuff so that you can stay in the zone, I guess is a good way of putting it, so that you can maintain your job and keep improving. So you've got to know all that stuff that we spoke about already. And then you've got to know database theory and design. You've got to know queries. You've got to be able to analyze queries. You've got to be able to do performance tuning. You've got to know your internals. What is a table? What is a data page? What is an index? What is a B tree? All of these things you need to know as a modern data professional. You've also got to know SQL. I know that sounds obvious, but you'd be surprised with how many people coming into this industry who are very good at other things, and then they suddenly have to come in as a DBA. A lot of people I know came into the position of a data professional accidentally. And in fact, a lot of you are familiar with the term accidental DBA. It is people who grew interested in managing the data environment who were the default person to do that because nobody else was interested, or it was just somebody had to do it. So people don't necessarily know SQL, even though they are in charge of their data environment. But this is something that you should know. You're also expected to know client-server model. So you've got 3-tier architecture. In other words, you've got your server, you've got your application box, and then you've got your database and your clients and everything interacting and interoperating and networks and blah, blah, blah. You've got to know operating systems. And guess what? SQL Server runs on Linux and Docker containers and Mac OS. It's a lot of stuff that you have to know there. And finally, storage technologies and networking. We're going to talk a lot about networking as we come up to the next few slides. So here's the poll. I want all of you who are watching to go here and answer this question. That's pollev, pollev.com/RandolphWest196. If you spell my name wrong, you're not going to find the poll, so good luck with that. What you're going to do here is answer just by clicking. It's an anonymous poll. You can skip the username that it asks for and just click on the versions of SQL Server that you've used. I'm going to leave that link up for a few more seconds, and then I'm going to speak a little bit more about versions, and then we're going to come back to see what the poll results were. So 5, 4, 3, 2, 1. What does the current landscape look like? So back to me again. In the old days, and we're not talking about that long ago, there were maybe 3 to 5 years between versions of SQL Server. You could be perfectly successful in your job only knowing the latest version and the last 2 versions. Things have changed dramatically now, though, with 2017, 2019, 2016, all of these versions coming so quickly after each other. You're expected to know a lot of stuff, and it might seem overwhelming. I get that. You don't want to feel too overwhelmed, though, because fortunately, some of these versions are no longer around. If you're still supporting them, which we're going to find out when you answer the poll, it's going to be tricky, right, to have to administer versions older than 2012. But I understand and acknowledge that it is a heavy workload if you have to know all of these versions and the new stuff. But that's why I'm here to help you today. And remember, according to Buck Woody, it's just SQL Server. And it's not just Buck who says that. It's a lot of folks at Microsoft who say that, and I've said it as well. It's just SQL Server. It doesn't matter which version you're using, provided it's version 7 or later, because they made some huge changes in version 7. Data pages are 8K in size. You've got a transaction log file, which needs to be on fast storage. You've got your data file, which needs to be backed up regularly with a regular database backup. You've got to do maintenance tasks. You've got to make sure you've got indexes. You've got to make sure that you tune those indexes and all that kind of stuff. It's just SQL Server. It doesn't matter if big data clusters or 2012. Yes, there's some cool features in between, but that's not really it's not really something to concern yourself with as a production DBA, that there are new features, because a lot of times, and we're going to probably see that in the results, hopefully you've actually done the poll, that people are using older versions. So it's okay if you're not completely up to date. So shall we see? Let's go back to the slides and click on this. And it says, okay, go back to the poll and see. And there we go. This is exactly what I expected to see. Most people who answered the poll have used 2005. And as you get to the newer versions, you'll see that drop off dramatically. I haven't seen anybody here using 2019. That is dramatic. That is dramatic. I cannot, there's no way to describe how, you know, we come to these conferences and learn about new technology, but then you've got to go back to your organization and you've got to help them get into the new stuff. But there's no way to describe that feeling of helplessness when you want to go and change everything, because you're still dealing with old versions. So again, being a DBA in the modern era, doesn't change much because you're not dealing with the new versions just yet. Yeah. So here we come to the part about what it means to be a DBA in the modern era, what you need to know. And we're going to start with a fundamental. I just wanted to point out here that I've changed the slides slightly because I know that there were issues with the streaming earlier in the week with the picture quality not being great for some folks. So I've made the text bigger. So if you are following along in slides that you downloaded, the content is exactly the same. It's just been refitted for the text to be a little bit bigger. So I just wanted to mention that. There are 1 billion nanoseconds in 1 second. A billion is a very, very big number. In fact, it is such a big number that if you started counting out loud to a billion, it would take about 30 years. A billion is a very, very big number. I just want you to appreciate how big a number that is. Humans are not good at understanding big numbers. I'm not going to speak about politics. Humans are not good at understanding big numbers. So what that means is you see a big number, your brain goes a little bit confused, and then you can't really understand it. So I want you to understand that that is such a big number, and I'm going to show you something that's analogous to that big number so that you can help understand it better and help yourself become a better DBA or data professional as a result. So with the understanding that there are 1 billion nanoseconds in 1 second, let's look at a graph. Now, this graph is difficult to read. I am stating that up front because I don't expect you to read it. What I tried to show here is the difference between one CPU clock cycle on a typical CPU of 2.5 gigahertz versus a ping time measured in the same scale from London to Cairo. And of course, you can't see anything until you get to the last 3 values. And it is just impossible to understand the magnitude of size difference between a CPU cycle and a ping time. So I tried to reduce it down a bit. Instead of having the CPU cycle and the L1, L2, L3 cache on the CPU and the DDR and the Optane PMEM and SSDs and 8 hard drives and all that kind of stuff, I tried to remove some things to help the scale improve, but it didn't help at all, because even at the scale of SSD compared to a CPU cycle, it is still 100,000 times 2.5 times slower for an SSD to perform an action than it is for a CPU to tick over. These numbers are so monumentally big that we need to look at them in a different way. So if you take one CPU cycle, so a 2.5 gigahertz CPU clocks over 2.5 billion times every second. If you convert that to 1 second, so one clock cycle equals 1 second, we see a very different picture about what these values mean. So with that in mind, if a CPU cycle is 1 second, a level 1 cache access, and this is in a CPU, you've got your socket. And on the socket, you've got a die, which is silicon. And on the die, you've got cores. You may have usually multiple cores on a CPU die now. So on the core, you've got the CPU itself, which does the transistors, the billions of transistors. And then there's next to it on the CPU core, next to the core on the same die, is the level 1 cache, which is very, very small, but very, very fast. And that's what we're talking about here. There's 3 to 4 levels of cache on the CPU die itself. So that's what we're talking about here when we talk about L1, L2, and L3 caches. So an L1 cache access takes 2 seconds if a CPU cycle takes 1 second. DDR RAM takes 4 minutes. We're not even in the same zone here. It's 250 times slower for a memory access on the motherboard than it is for a CPU cycle. So when we say to our storage team, it's not the database, what we mean is that the CPU on the database server is waiting for data. It's waiting 4 minutes for data from memory So if you look a little bit further down, NVMe takes 17 hours, SSD access takes 3 days. And if you are on a SAN, which is server attached, storage attached network, your network is going to take 3 days to return data. So your CPU is idle most of the time, guaranteed. Your CPU is idle most of the time, guaranteed. If your CPU is not idle, if your CPU is doing way too much, hire me, please, because I can fix that. You want your CPU to be running between 5 and 15% on a SQL Server instance, because that means it's doing what it needs to do. If it's using more than that most of the time, if it's not idle most of the time, we need to talk. So this is a fundamental understanding that you have to have as any form of DBA, whether you're a single person in your organization or if you're part of a massive team. It takes a long time for data to reach your CPU. Doesn't matter what kind of hardware you have. Got it? Good. So let's talk a little bit about the CPU. We spoke about the fact that it's got a die, and on the die, it's got multiple cores. I'm just waiting for there it comes up. So we talk about cores. In the old days, we had a single core. We have a socket on the motherboard, and inside that, a CPU core, and the core has got a certain speed. And if it gets too hot, then it melts. So it's limited to a certain temperature. So if it gets close to that temperature, it'll clock itself down. That's the first thing you have to understand. That's why CPU clock cycles haven't gone much above 4 gigahertz, because at that speed, the transistors get too hot. And because they're so close together, they can't actually do what they need to do. It fails. It basically fails because it's too hot. So it has to clock down. So a core is a physically distinct processing unit on the same die, which is that silicon die we spoke about. On a SQL Server instance, single-threaded performance matters most, especially with OLTP. OLTP stands for online transactional processing. Online? I think so. Janice, are you there?
I am here.
Does OLTP stand for online transactional processing?
I believe it does.
Thank you, Janice. You are amazing. That's Janice, my proctor, my moderator for the session, who I mentioned earlier. So what we're saying here, for most transactional workloads, in other words, you've got stuff that's reading and writing to your database, you've got your apps that are reading and writing, you've got the stuff that you normally see on a database instance is OLTP. So single core performance matters most because a lot of those transactions are short-lived. They run in a matter of milliseconds. A millisecond is 1,000 nanoseconds. 1 million is 1 million nanoseconds. See, even I get confused. A millisecond is 1 million nanoseconds. So for SQL Server to run something in milliseconds, the CPU is still waiting. So because those transactions are short-lived, you want them to run on one single CPU core because it'll be over faster. If you have to start spreading the workload across multiple cores, there has to be a coordinator thread that manages the distribution of the workload between those cores. So if you can avoid that by bumping up your bumping up your cost threshold for parallelism and dropping your max degree of parallelism to make sure that that stuff runs on a single core as much as possible, then your performance is going to go better. And the faster your single core performance is, the better for those transactions, which means that I'm going to come back to me again, because this is important. You need to look at me in the eyes. It means that power saving settings have to be off. Because if you're paying all this money for these fast CPUs, and you're paying all this money for SQL Server licenses, which are expensive, you want to get the best bang for your buck. That's not buck witty, that's your dollars. You want to make sure that you're getting the best performance out of your hardware. Otherwise, you're just leaving money on the table. So if you get fewer cores with a higher CPU clock speed, you're going to get better performance for most OLTP workloads. I said most because it depends. I'm a data professional. Everything depends on something. But for most transactional-based workloads, a higher clock speed with fewer cores is better. Higher clock speed means it can get hotter, and if it's got fewer cores, it doesn't need to worry about scaling down because of those multiple cores. Okay, I'm going to go back here again because it says at the bottom there are new max DOP options in SQL Server setup. I do not remember the version. I think it's with 2019. You can set the maximum degree of parallelism on your machine when you install SQL Server for the first time. This is different from the defaults of before, where it was always set to 0, which means use all of them. So what happens now when you install SQL Server on your machine and you're using the graphical user interface, you can also do this through a scripting environment, but when you step through the UI, it actually says, hey, we've noticed that you've got X number of CPU cores. We would like to configure this to Microsoft recommended settings. And the recommended settings are, if you have more than 8 cores, then you should set it to 8 as a maximum, but that depends on a number of factors. But the point is you now have that option during setup. In the old days, you had to change it after the fact. I'm all for a product that configures the tool for you when you set it up. I really am. Speaking more about CPUs, and this is an important thing that we have to think about, hyperthreading has been sold, and hyperthreading is a registered trademark of Intel. I just want to point that out. It's actually called simultaneous multi-threading, SMT. And what that means is you get an extra boost of around 15% headroom on your CPU. So if you've got hyperthreading enabled on your Intel CPU, that means that your CPU can get an extra 15% boost with it enabled. It does not mean that you have extra cores. It does not mean that if you have a 1.2 gigahertz CPU and you have hyperthreading with that, it doesn't mean you get a second 1.2 gigahertz CPU. That is very important when it comes to virtualization. We're going to talk a bit about virtualization shortly. Finally, on CPUs, you may have heard of a company called AMD. For a while, it's not Microsoft's fault, but for a while they were giving you a discount on your SQL licenses if you had an AMD CPU. That's no longer the case because Ryzen is actually better than Intel in a lot of cases, especially when it comes to single-threaded performance for CPUs for SQL Server. Glenn Berry has a blog post, which I read recently, I think it was in the last couple of weeks, about which Ryzen CPU, so that's an AMD brand, which Ryzen CPU is better for your SQL Server instance. They are as good, if not better, than Intel CPUs for single-threaded performance. So it's definitely something to think about now. They're not what they used to be. AMD has caught up to Intel. And then, of course, I mentioned this earlier, always disable power saving settings. You want to make sure that you're getting the best performance for your money. Yes, it does affect the environment. I respect that. But if you're spending $8,000 US or $9,000 US per core with a minimum of 4 cores on Enterprise Edition of SQL Server, you want to make sure that you're getting the best value. So I'm going to go to you and ask if you have any questions. Please put them in the Q&A. I understand that the poll got full and more people couldn't answer the poll. I apologize for that, but it's free and I didn't have a lot of time to set it up. If you would like to provide some feedback, or if Janice has any feedback that you've mentioned in the discussion, now's the time to mention that, Janice. Otherwise, we'll continue.
There's a number of people who use very new systems who are offended that they weren't able to answer the poll. Well, maybe not offended. That might be too strong a word, but yes.
As somebody who presented on SQL Server on Linux on Tuesday, I value the fact that you are using newer systems than the ones that were provided on the poll or answered on the poll. And I thank you for using 2017 and 2019. I thank you for using big data clusters. My friend Ben Weissman, who's unfortunately German, presented on something to do with big data clusters recently. He's quite the expert on that. So If you're working with that new tech, cool. It makes it better for all of us. It's just like cars. If you watch Formula One, you may get bored about them going round and round in a circle. But the advancements that they've come up with for Formula One engines will eventually make their way into our cars, so that 10 years from now, 20 years from now, we'll see things like, I don't know, ABS braking. Well, that came from planes, but still, we'll see recovery energy systems for our cars, which we're seeing now with electric cars. So just like that, all the new stuff that you're using with SQL Server, big data clusters, and 2019, and using it on a Linux, that's all going to trickle down to the rest of us. So thank you for using the new stuff. All right, moving on to memory. Again, if you've been following along in the slides that I uploaded, I would have called these sections fundamentals, but here, just to make the text a little bit easier to read, I'm just using the subtitles here. So let's talk about memory. I used an icon for a calculator there because I couldn't find anything else that kind of meant memory, because the one that it recommended was a database icon, so I didn't use that. So let's talk about memory. RAM stands for random access memory. On your computer's motherboard, you have the socket for the CPU or multiple CPUs, and then you have slots for RAM. Now, if you've got something called NUMA, which stands for non-uniform memory allocation, you have multiple areas of memory per CPU socket. That's generally what we see these days in server hardware, where you've got multiple sockets, and each socket of CPU has its own bank of memory. So when we talk about RAM, we're talking about memory. And if you remember back to that slide where I talked about the time difference between a CPU clock cycle and memory access, this is where you go from 1 second, if one CPU cycle is a second, to 4 minutes. So RAM, even though RAM is really, really quick, it can take a lot longer for that data to reach memory, from memory to your CPU. And that's why we say, if you're running a SQL Server instance, you need to get as much of your data in memory as you can for it to have the optimal performance. Obviously, there isn't enough space on the level 1, level 2, and level 3 cache on your CPU. So the next best thing is to have your database or your biggest tables in memory. And this is going to help your performance dramatically. So we're going to start with max server memory. Some of you watching this may know me from my blog post called the Max Server Memory Matrix. And on that page, I list in 4 GB increments, I list the recommended amount of memory you should assign to your SQL Server instance up to 2016, but not including 2016. There's a little bit of it depends why that happens. But the thing here to remember is that when you install SQL Server the first time, up to but not including 2019, you were given all of the memory. The default is 2.1 petabytes. It's a huge number again. This is a number that our brains cannot comprehend. The default is too high. The default's too high because you're taking memory away from Windows. We'll talk about Linux separately. When SQL Server starts up and it has the default of 2.1 petabytes, it's going to use all the memory it can. Then Windows is going to say, hey, I need some of that. I need to run the drivers, the device drivers for the hardware. I need some of that for some of the other software you may be running. You could be running SSRS, which is reporting services. You could be running integration services. You could be running analysis services. There's a word I can't say. You could be running Google Chrome, for all I know, and Google Chrome is a known memory hog. So whenever you open something else aside from SQL Server on the same instance, you're going to run out of memory and things are going to compete, and Windows is going to say, hey, I need to get some of that back. And then you're going to get a little bit of paging where whatever's in memory goes to disk. And I think it was hours. It was measured in hours if you have an NVMe drive, which is the fastest storage you can get apart from something else. But the fastest storage you can get NVMe is that much slower than memory. So if you have to go to disk, it's going to make everything slow. So when we talk about max server memory, we want to leave some headroom for the operating system. I spoke a little bit about Windows. For Linux, there is a default configuration for SQL Server where you get up to 80% of the physical memory. The reason for that is that in Linux, you've got something called the out-of-memory killer. It is indiscriminate. It will kill whatever it feels like. It is an operating system fail-safe feature to make sure that the server doesn't go down. And if your SQL Server uses more than 80%, it'll kill it indiscriminately. You won't get any warnings. So on Windows, you have to set the max server memory. On Linux, if you don't change that 80% setting, and if SQL Server is the only thing running on that server, then you should be okay with not having to set that max server memory setting, because it doesn't really matter if it's using that 80% value. If, however, you have other things running on that machine, you want to bring that number down, that max server memory down. If you have, and I mentioned on the slides, if you have column store and in-memory objects, you also need to reduce down that max server memory, because those things get their own memory. And depending on the license that you have, standard edition versus enterprise edition, and even developer edition and Express Edition have different amounts of memory that are available to column store and in-memory objects. And they also depend on the number of databases you have and so on and so forth. But you have to keep in mind that your max server memory setting should be adjusted down. And the page that I set up uses an algorithm from Jonathan Cahias from SQL Skills. But if you don't want to use that algorithm, if you want to just do some sort of, I don't know, you want to guess, you don't want to go to all that detail, don't set it to 95% of physical memory, especially if you have a lot of memory. Because on bigger systems, Windows still needs to be able to access memory. It still needs to access certain things. So don't go give all of the memory in your computer to SQL Server. Again, just like with the max degree of parallelism, we have a new configuration option inside SQL Server Setup where you can set the max server memory options. And again, it gives you a recommendation. Microsoft's recommendation is slightly different to Jonathan Cahias' one, but it's okay as long as you're changing that setting. So Janice has just told me that there were 2 questions. So Janice, if you want to come in and share them with us, that's great.
Sure. There's actually 3 now, and now might be a good time for folks to add more questions.
Awesome.
So is there a good resource for max memory settings on SQL servers running things such as SSRS, SSIS, SSAS?
That is a very good question. Thank you for asking. If it is a 32-bit program, then you get up to 4 gigabytes of memory available to that tool or whatever, or that service that's running. So on older versions of SQL, it was easy. You get up to 4 gigs of RAM for each of those things of virtual memory, and then you could assign it accordingly. So if you had 64 gigs, you could give 4 to SSAS, 4 to SSRS, and so on, and then reduce down your max server memory for SQL Server. So firstly, I'm going to say this because this is the correct answer. Don't put everything on the same box. I know that that's not practical, especially if you're running in a small environment and of course everything's shipped in the same box. You have a checkbox when you install SQL to say, I want all 4 of those things. What I would do is there's a way to monitor the amount of memory that SQL uses. So I would bring it down. I wouldn't say way down. So if you've got 128 gigs of RAM in your server and you've got everything installed, you want to see what your SQL Server is using, what it gets up to, because it will never use it all if it doesn't need to. It's only if it gets big queries, it'll take it and then it'll never release it. So you want to see on an average day how much memory your SQL Server instance uses, and then drop max server memory down to that. One thing that I wanted to mention here for max server memory is that is for the buffer pool. It doesn't mean everything, because in 2012, Microsoft changed the architecture of how it uses memory. So there's a bunch of other things that use memory. over and above the buffer pool. The buffer pool is where all the data pages are in memory. And then you've got your query cache, you've got a whole bunch, your plan cache, and a whole bunch of other things. That's not included in your max server memory setting on 2012 and higher. So keep that in mind as well when you set that value that it could use more, and generally does use more. So to answer the question, it depends, but it depends on how much memory SQL's using. Bring that down. And if you need more, bump it up. For the others, you're not going to be running an SSAS cube and a massive reporting query at the same time. I hope you're not. If you are, you might need to scale out and do some moving of things around. But you're going to have times of day when SQL's busy. You're going to have times of day when reporting is busy. You're going to have times of day when you're building a cube. Hopefully those are not the same time of day. If you've got to that point, it might be time to look for a second license or offload that workload somewhere else, maybe into the cloud. You could scale up, scale down when you're not using it. But to answer the question, don't give it the most amount of memory if it doesn't need it. Because yes, it'll use it if it's available, but it may not need it. Thank you, Janice. Next question.
Okay, next question, thank you, Randolph, is how critical is changing the power saving settings on the host in a VM versus guest, etc.?
You know what they say as a professional speaker. If it's a good question, I don't know the answer. If it's a great question, I do know the answer. And if it's an excellent question, I have a slide for that. This is somewhere between good and somewhere between excellent and great, because I think I have a slide for it. You need to make sure that your power saving settings are disabled at the hardware level, so in the BIOS, as well as in the operating system, especially for virtual machines. And while we're on the topic of virtual machines, I mentioned hyperthreading. You've got to make sure that when you assign virtual cores to your VMs, that you're not assigning a hyperthreaded core as an actual core, because that's going to mess things up entirely. So to answer the question, yes, you have to disable power saving at the operating system and at the host level, including the BIOS. And that might require a server restart, so keep that in mind. Next question, please.
Okay, Thomas asks, you mentioned that you should try to minimize parallelism for performance with OLTP. Should we try to force parallel queries into serial when the difference in performance, according to the optimizer, won't be large?
Why? No, it's a good question. I appreciate your question, but the answer is, why do extra work? Our jobs as data professionals are to let SQL get on with it. If we try and overthink the problem, we could complicate issues. On 2016 and higher, you've got the query store, which will keep track of your plans forever, right? So as soon as you turn on query store, you will have a history of all the plans that were run for all your queries. And you can use the query store to your advantage. Yes, I understand that in a lot of Microsoft products, you have to wait for version 3 of the thing for it to be great. So version 1 of the query store wasn't great. Version 2 in 2017 was better, and version 3 in 2019 is even better. And Aaron Stellato, who is also with SQL Skills, I promise you I'm not just favoriting them. I just happen to know that Aaron is good at query store. Aaron has a lot of feedback about how to use query store to your advantage, how to set it up correctly, because you can't just click next and done. You have to configure your environment correctly. So go and look at what Aaron has written about query store, and then you can see, depending on the kind of queries that you're running, if forcing maxstop down for that query is going to help, or maybe you need to set the cost threshold for parallelism higher for the whole instance, or maybe it was just an anomaly, and you will look in the query store and it'll say, hey, when that query ran, I got a bad plan, but it has a much better plan before. So I would always defer to the tools that are available to me instead of trying to force things unless it's a significant difference. So if it doesn't make much of a difference, I wouldn't say yes to forcing it to run serial as opposed to parallel. And you said there was another question, Janice?
There is one last question in the queue. Thank you, Randolph. The question is, how does SQL Server handle memory when running things from the integration services catalog? Should this be split into different servers as well?
the SSIS catalog, SSIS DB, is a database. So it has a plan cache. It uses the buffer pool. So if you are worried about performance from that point of view, it might make sense to split it up, keeping in mind that you would need a second license for that. And if it makes sense financially and performance-wise to do that, then do that. But yes, it does use resources on SQL Server as well as SSIS. So if you are worried about that, monitor your instance. Make sure that it's not something to worry about. So you might be worried about that, then you go and measure it. Once you've got a baseline, then you can compare it against next week or last week, and then you can say, yes, it's a problem. No, it's not a problem. So I hope that answers your question. Get a baseline and then you'll know. So that's it for questions, Janice, for now?
It is, yes.
Awesome. So we're going to go back to the slides. And we spoke about all of that stuff. So let's go on to the next one about memory. Ha, this one's cool. ECC stands for error correcting something. I don't ever remember what the other C stands for. But basically, memory chips on the DDR shape, the format, the physical thing, are so densely populated that a gamma ray from the universe can flip a bit. So let me say that again. Background radiation from the universe can change the data in your memory if it is too densely populated. And generally, I wouldn't say this is a hard and fast rule, but in my experience, 32 gigs and more has the chance of being flipped by background radiation. I'm not saying that's going to happen, but I think this was an IBM's study that I read several years ago, that this background radiation problem is significant or more noticeable if you have 32 gig DIMMs or higher. And of course, we've got 32 gig DIMMs, because that's, I mean, RAM, we're looking at 256 to 512 for the average server these days, if you've got the money for the license. So always buy ECC RAM for your server, because you do not want your data changing in memory. You don't, trust me. So if you use ECC RAM, it has a little check. It has a little bit check that makes sure that whenever it writes to memory, that it is consistent. It's kind of like the same thing that happens in your data page when you write to disk or read it from disk. That little checksum is kind of what ECC does. And here is probably the most contentious point on my slides. Lock pages in memory, LPIM, is a setting that you can turn on in the policies, group policies. That's what I was thinking of, the words. You're going to see me staring off into the distance in a very actor way. If you can be sure that your SQL Server instance is the only thing on the box, and you have to be sure, then turn it on. And then what will happen is Windows will take the memory that's assigned to SQL Server and keep it there. It'll pin it in memory, which is great. If you've got something else running, you've got a problem, because then it's going to blue screen. I read, oh gosh, it was on Twitter. I don't remember who wrote about it, but there was a problem recently, which was about a SQL Server instance that was blue screening because there were multiple instances or something happening on the box, and they weren't aware of that. And because they had lock pages in memory enabled, it was causing the machine to blue screen because it couldn't free the memory for the operating system to assign to something else. So you have to be very careful with the setting. I'm not saying don't use it in one case. If you have virtual machines on a shared host, in other words, more than one VM on that host, don't use LPIM. Otherwise, be very cautious with it when you do use it. I think that's the nicest way of putting that. There might be comments or questions on that, and I'm happy to hear those. The conversation that I point you to is between Brent Ozar and Jonathan Cahias from a few years ago now about whether you should use LPIM. I always defer to what's best for my environment. If I have one instance running on a VM and it is the only VM on the host, I don't see any point in turning it on anyway, because it's the only thing using memory. So for me, I don't use it. I've never found an occasion to use it. But if you go and read the 2 points of view from those two folks, Brent and Jonathan, you will be able to make your own decision on that. And I would encourage you to read that. It's a long discussion over a series of blog posts, but it will give you more perspective. And of course, book plug time, I wrote about it in SQL Server 2019 Inside Out. And all of the things that I've mentioned in the book are covered in there as well. What I've just mentioned now are covered in the book. So turn it on at your peril, I guess. So moving on to my favorite part of the conversation, storage. Faster is better. And I covered this in the memory section. I said that if you want your SQL Server instance to perform at its peak, you want to put as much stuff in memory. If it doesn't fit in memory, then it'll go to disk. It'll go to disk because you have less memory than you have database size, and you'll have Windows that's doing paging. You'll even have Linux that does paging. So you want faster storage, the fastest that you can afford. And now we'll talk a little bit about how storage affects your SQL Server instance. You've got tempdb, you've got your transaction log files, you've got your data files. If you're using in-memory objects, you've got those files to worry about as well. You've got log files, you've got trace files, you've got a bunch of other things as well, which I can't think of off the top of my head right now. And in order that I gave you is the order of performance. TempDB is the most important, because unless you're using a certain feature in SQL Server called accelerated database recovery, TempDB is going to be the hardest hit database on your system. And even if you do have accelerated database recovery enabled on 2019, it doesn't mean that TempDB is not going to be hammered, because everything, including sorts, joins, all sorts of things that you don't know about necessarily, are happening in TempDB. So it has to be the fastest storage you've got. Then is your transaction log file for your databases. And these days now, with the way that storage appliances work, especially with Pure Storage, and I talk about HCI, which is hyperconverged infrastructure as well, you've got these arrays of solid state storage. So you don't have to really worry about random access anymore. In the old days with hard drives, you had to make sure that it was sequential access versus random access. It's not too much of a problem these days, but still keep it in mind, certainly, that despite all of these new advances in storage, you still want the fastest storage for your TempDB and your transaction logs. You can talk about RAID and all that kind of stuff. A lot of these newer storage appliances hide how they're persisting to disk. I would recommend watching Argenis Fernandez's presentation on 8KB that happened a few months ago. 8KB was another conference that was a day-long conference. Argenis talks about the stack of where SQL Server starts writing to disk, gets to the operating system, and then what happens beneath that. And what happens beneath is dramatically different to what you'd expect. That's why I'd encourage you to watch that if you're more interested about how storage works. It's not just write to the disk and then it's done. It certainly isn't. So keep that in mind as well. Solid state eliminates the seek time. On a hard drive, you have a spinning disk, and the spin requires a seek. But because solid state doesn't have that, it is faster by default, but it does have other issues around write amplifications and so on. You need to make sure that when you test the performance of your storage subsystem, that you test that with large block sizes. The default these days is it'll test it with a 4 kilobyte block size or 512 kilobyte blocks, 512 KB, yeah, 4K, 512 byte, sorry, block size. What you want to do is test your block sizes with 1 meg, 2 meg, maybe 64K, because that's what SQL Server does with its extents. But you want to make sure that you're testing with large block sizes, because SQL Server writes in large blocks. IOPS stands for inputs and outputs per second. IOPS means reads and writes, kind of technically. Inputs and outputs per second. So that's why you need to test with large block sizes, because it could be very fast with small block sizes, 512 bytes, but with SQL Server, you need to have bigger blocks. And then there's something called drive queue depth, which is just as important as IOPS. So drive queue depth is like it says in the word, it's a queue. So I have a write or a read that I want to submit to the disk. It goes and puts it in a queue. And then that queue depth needs to be big enough so that it can handle everything in the queue. Otherwise, you get your enemy, which is latency. Latency means it has to wait until the queue is empty before the next one can go in. And that is the antithesis of performance. I spoke to an organization recently where their queue depth was causing their storage system to have latencies measured in minutes. For optimal SQL Server storage, we talk about milliseconds. And in fact, I put that on the next slide, I think 10 millisecond latency. I don't have it on this slide. But you want to measure latency in milliseconds or nanoseconds. And if you're measuring your latency in minutes, then you're waiting months for your data if a CPU cycle is 1 second. Remember that. So please make sure that when you buy your storage, that it has good performance for large block sizes for your IOPS, and that it has a deep queue depth. And yes, you will end up paying more money, but it's SQL Server. You're already paying all that money for the license. You need to make sure that your hardware can support it. I've said here that malware detection is the enemy. And what I mean there is, obviously, malware is the enemy. So you need to be able to check against your with your antivirus that you're not being infected and all that kind of stuff. But defense is done in depth. So during the keynote yesterday, it was yesterday, the point was made that defense in depth is something that happens in the Azure cloud. And it's the same thing that should happen in your environment. You should have a firewall. You should have some sort of monitoring tools that detect anomalies. You can log all you like. As long as you're checking what's happening there, if you're not doing the checking, it's meaningless. So your defense in depth has to include stuff on the perimeter of your environment. You have to do training for your employees. You have to do training for your customers. You have to make sure that they don't click on phishing links. You have to do all these things. And then you need to worry about antivirus. So for SQL Server, there is a page on Microsoft's website, which is quite easy to search for in your favorite search engine, about exclusions for SQL Server, because you do not want your SQL Server being stopped every time the antivirus wants to check that write that it just did. Because SQL needs to write fast and it needs to read fast. And it has certain flags in its configuration that bypasses some of those caching checks in the operating system level. So it needs to be fast. It needs to be so quick that an antivirus cannot actually keep up. So for SQL Server, you want to disable file system scans. You want to disable a whole bunch of things, and that URL that you can search for in Microsoft Docs will take you through the entire thing. It's a very in-depth thing. You may decide you only need to disable the SQL Server executable and the folders, but there's a lot more stuff that you can think about. And it also looks at SSAS and SSRS as well. So that's why I say malware detection is the enemy. It's not that malware shouldn't be stopped. It's that you should be using an in-depth defense system for your environment before worrying about an antivirus on your SQL Server instance. It's okay having an antivirus installed as long as you exclude SQL Server. I mentioned briefly hyperconverged infrastructure recently when I was talking about storage arrays. HCI is the next best thing. In fact, is the new best thing I meant to say, not the next best thing, is even Azure Stack, I think it's called, is a cloud in a box, basically. So you've got your CPUs, your storage, your memory, and all this stuff with redundancies all in the box. And then you can have multiple nodes and redundancy connections between them, and it's great. Except that with HCI, you're sharing CPU with the storage array. In a standalone storage array, you have dedicated CPU to run the storage, so it performs as fast as it can. With HCI, the only thing that you have to watch for here is that you have less CPU available to you because some of it is being used for the storage as well. So I'm not saying don't use HCI. I'm not saying that at all. I'm saying that if you do have an HCI or hyperconverged infrastructure, that you need to keep that in mind, that CPU is not entirely dedicated to your processing of your SQL Server instance or your operating system, because there's also stuff for the storage layer. Earlier, I said that NVMe is the fastest storage you can get, and then I had a little disclaimer there. This is what I was talking about. Hybrid buffer pool is a feature in SQL Server 2019 and maybe 2017, if I remember correctly, which uses storage, I think even 2016, which uses storage to increase the size of your buffer pool on SQL Server. Now, if you're comparing performance of your solid state versus your hard drives, your spinning drives, then a hybrid buffer pool on solid state might make sense. In modern computers, you've got an even better way of having fast storage by having it basically in memory. Persistent memory is where you get your DDR RAM, and on the same physical form factor, you've also got solid state storage. So this is a device that plugs into your RAM slots and is backed by solid state storage. Now, because it's a backup feature, it also has to be powered independently. So it will have its own power supply. And what that allows you to do is, especially in 2019 on SQL Server 2019 on Windows and Linux, you've got this ability to bypass the storage layer entirely. So SQL Server goes to memory as it would normally, but then it doesn't need to go to disk because all the storage is in memory. So it uses memory copy features. And of course, you've got to have enough memory for this to work. But what happens is if the machine loses power for some reason, then whatever is in that pmem DIM will get written to the solid state storage that is attached to the same form factor. And then when you restart the environment, it just pushes it back from that into memory and away you go. So it's a lot faster. And because it's in a DIM form factor, you don't have to follow the bus down to the storage subsystem to get the data out. So it takes a lot less time. So it's a lot faster. So it's the next best thing to having it in memory. Persistent memory is very cool, but also very expensive. For now, it'll come down eventually, I guess. So with 12 minutes to go, let's talk about the network. I said that storage was my favorite section. This is my least favorite section because this is the one that people often forget about when they're talking about the cloud. So let's get into it. Right at the top, I say the network is slow. Latency is the enemy. You always want under 10 milliseconds. On that slide that I showed you right at the beginning, where I took the CPU and then the memory and then the storage and then the network ping times from London to Cairo, it was 100,000 times or something, 500,000 times or 200 million times slower to do a ping than it was for CPU. That's what I'm talking about here. It is just so dramatically slow to use a network. Even if you have the best latency of less than a millisecond. Milliseconds, remember there's 1 million milliseconds in a nanosecond. And a CPU clock cycle is half a nanosecond. I joke here and I say it was DNS because there's a running joke that if something goes wrong with your network, it's because DNS failed somewhere along the line. It is a joke because this is not always true, but it is true enough times that it's become a joke. If you are using failover clustering with availability groups and things like that, you need to be very aware of your CNAMEs when you set up your environment. And what happens is if something fails over and you get a new IP address for a particular device or a particular endpoint, if your time to live, your TTL, is less than 5 minutes, let's say it's the default of an hour or 8 hours, it's going to take 8 hours to fail over, whether you have the best technology on the block or not. When you set up an availability group, make sure that your CNAME records are set to 5 minutes or less, so that when a failover happens, it'll take 5 minutes or less. That's important. This is a little bit of common sense, but common sense is not common. And I realize that a lot of folks coming into the role of a data professional are new to it and come in from a different point of view. Maybe they were programmers. So, and I love programmers because I am one. I am a software developer. I wrote my first code on a console system in the 1980s, which I broke. Sorry, Mom. And programmers are good at writing loops. And in a loop, you get a data set, and you've got your first row and you do something with it. Then you got your second row and you do something with it. And you get third row, and it's fast because it's on your machine and it's quick. Everything's cool. And then you deploy it, and then you've got 10 million rows, and it's a little bit slower because SQL's actually pretty good at millions of rows, surprisingly. Billions of rows, then it starts slowing down, and then your users start complaining. So what I'm saying here is, there are some techniques that you might have learned in your previous life as a software developer that do not apply to SQL Server. Relational database management systems prefer set-based operations. If you can do the same thing on multiple rows at the same time, then it'll be a lot faster. We're talking orders of magnitude faster. So this is a phrase from Jeff Moden, rebar, row by agonizing row. Please avoid using rebar or row by agonizing row, which includes cursors, programming loops that we've spoken about. And for network stuff, the reason it's important and why I put it here into the network section is because something as basic as setting no count on will improve performance because it doesn't need to report back to SSMS or your client how many rows were affected. And by eliminating that callback to the client, you're making SQL Server deliver the contents of the set-based operation that you're trying to do a lot faster, because it doesn't need to do that back and forth messaging to say 10 rows affected, 1 row affected. Turning no count on with a network connection will make your results happen faster. And please, 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 please don't use Profiler in a production environment. See, I said in a production environment. Profiler is a cool tool. Profiler is included in SQL Server 2019 still. It is deprecated, which means that Microsoft's not going to make any more changes to it, but it's still going to be there. It's not going away. However, if you're using Management Studio 17 or higher, then you have something called extended events, and 17.3, in fact. Extended Events Profiler, XE Profiler, which does two things, and it does two things very well. It copies the two most popular types of profiler trace that you can do. One of them is a T-SQL one, and one of them is a regular one. And you can run that XE profiler trace instead of a regular profiler thing, and it'll be a lot faster because the overhead of extended events is reduced because it's not returning a row by row thing. It's doing it asynchronously in a set-based way. So there is still an overhead with extended events, and some of them you have to be very careful with. But extended events generally are a lot more performant, which is a word from the 1980s. It's a lot more performant than using a profiler. I see we have one question from Janice, so let's go to the question quickly, and then we've got 5 minutes, and then we'll wrap up here.
Okay, so this is a question about the antivirus malware scanning. So Josh's new vendor has recommended to not put SQL in exclusions because it doesn't scan at the file level and is looking for patterns instead. Should Josh still put in exclusions, or should Josh listen to the vendor?
The answer to that question is Josh should listen to Microsoft's recommendations, which are to disable malware protection on SQL Server, because it's not just the file level that we were talking about, because you can also exclude the process itself. I would assume, and this is an assumption, so please take this with a grain of salt, Josh, that it uses a filter driver. So there's something running that is analyzing, it's trying to do pattern matching or something like that. I would turn that off because it's going to slow SQL down. Whatever it's doing will have a hardware interrupt somewhere. So it'll either come in at the network level or the memory level, and it'll slow things down. And depending on where it happens, it could be dramatic or it could just be a small overhead. But if you're paying all this money for your license and you've already turned off your power saving and all this kind of stuff, you want to get the best performance. The chances of SQL Server, because it is the most secure RDBMS product in the last 9 years, the chances of it introducing a virus into your environment are small to begin with. Secondly, if you have followed best practice with defense in depth and you've isolated your SQL Server instance to its own VM or its own hardware, and you've got a proper perimeter security on there, even if it does get infected and you don't have sysadmin as Windows administrator rights on it, it doesn't matter if it gets infected, right? Because you've secured your environment correctly. So in my, it smells wrong. It's like a code smell, but with configuration. It smells wrong. So I would push back on the vendor and I would say, if you can demonstrate that it does not cause performance issues, so you're giving them the onus of proof, then you can say, well, we'll test it. And then test it. And I said this before, if you've got a baseline, you can say, this is how SQL performs with the antivirus enabled. This is how it performs without the antivirus enabled. And compare the two. Run a regular workload and see how it compares. And if there's no difference, cool, then keep it enabled. But keep in mind also that you've got to have your perimeter secured as well. So if you set everything up correctly, you probably don't need it anyway. So that's how I would answer that. We got 3 to 4 minutes left, so I'm just going to get back to the slides here. Everything in the cloud is defined by the network. In other words, when you set up a VM and you connect regular storage to it, it's going to use software-defined networking. It's going to use software-defined storage. It's going to use everything that's connected is via the network. So the fastest you can have your storage is as fast as the network connecting it, unless it's physically attached to the machine. So be very careful when you do a lift and shift to the cloud. Be very careful what type of storage you choose, because unless it's physically attached to the machine that you're renting, it could affect performance dramatically. Lifting and shifting is not one and done. You have to do testing. So please keep that in mind. And let's talk about virtual consumers, which is my word for Docker containers and VMs. I call them virtual consumers because they're basically the same thing with a different abstraction layer. A VM is abstracted at the hardware layer, and a container is abstracted at the operating system layer. So what that means is you can fit more containers on the same hardware because it doesn't have to replicate the operating system as well. That's bypassed. I say that VMware and Docker are market leaders, but Hyper-V isn't going away. So if you're looking at these technologies, that's cool. It is cool. Docker will allow you more compute power on a piece of hardware than a virtual machine will, because you don't have to reinstall the operating system. It's less to patch. There's a lot of advantages. I speak about Kubernetes here because Kubernetes is the way to manage containers. If you've got more than one container, Kubernetes. OpenShift, which is a competing technology, is still Kubernetes under the covers. Azure Kubernetes Services, or AKS, is the same thing. And if you have Linux knowledge, it will help. If you don't have Linux knowledge, it's okay, because AKS, which is Microsoft's offering, and others will be able to do the management layer for you. And I've put here that Windows containers exist because they do exist. That's all I'm going to say about Windows containers. And finally, in my last minute, because I've timed this perfectly, let's talk about management. Managing SQL Server and instances and Kubernetes and all that kind of stuff all comes down to the same thing. You've got SSMS, you've got Azure Data Studio, and if you're on Windows, you now get both in the same package. You've got your command line tools like SQL CMD, MS SQL CLI, and BCP. And you've got PowerShell. Now, DBA Tools is the way you should go. 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 Thank you, Chrissy Lemaire, for DBA Tools and her team. And most of it's cross-platform. DBA Tools runs on 75% of its things run on Linux as on Windows. DBA Tools. Victory. And that's the end of my talk. If you want to get hold of me, please email me. Here's a link. Here's my email address. Here's my Twitter account. And I'm done.